Good morning, all of you. Welcome to Sri Jayendra Rank Zone. In the previous lecture, we have discussed about buffer solutions. Now, in this lecture, we'll discuss new topic, that is salt hydrolysis. Almost we are going to finish this chapter. So now in this lecture, we are going to discuss salt hydrolysis, and in the next lecture, we are going to discuss solubility product. So please listen carefully. This is also an important topic in ionic equilibrium. It's very important chapter. For every entrance exam, definitely you are going to get at least 2-3 questions from this chapter. So please listen carefully. Let us start now. Salt hydrolysis. The phenomenon of interaction of cations and anions of a salt with water to produce acidic, basic or neutral solutions. This is not nature. Solutions is known as salt hydrolysis. Just like it is nothing but reverse of neutralization. Reverse of, in simple words, I will tell you, it is nothing but reverse of neutralization. What is neutralization? Already you know. When acid combines with base, it forms salt and water. When acid combines with base, it forms salt plus water. So that is called when strong acid and strong base. So this is called neutralization, and reverse of neutralization is called salt hydrolysis. The name itself suggests that salt hydrolysis. What happens when salt is dissolved in water? So when a salt is dissolved in water, it undergoes ionization to form cations and anions. Example, the anions Cl minus Br minus NO nitrate ions, etc. of strong acid, and cations sodium plus potassium plus calcium plus etc. of strong bases gets hydrated but do not hydrolyze. So the other category of salts undergo hydrolysis. So what is the important point here? Salts obtained by the means of salts of strong acid and strong base. Salts obtained by means of strong acid and strong base do not undergo hydrolysis. Very important point. Do not undergo hydrolysis. Whereas other types of salts will undergo hydrolysis. What is salt hydrolysis means? When a salt is dissolved in water, what happens to the salt when it is dissolved in water other than the salts obtained by the means of strong acid and strong base? Because strong acid, strong base do not hydrolyze in water. So that's why they do not undergo hydrolysis. So very important concept. So what is in general, what is salt hydrolysis means? It is nothing but almost it is reverse of neutralization. Reverse of neutralization. What is neutralization? When an acid combines with base, it forms salt and water as the only product. That is called neutralization reaction. So similarly here, salt plus water gives us acid and base. So that is called reverse of neutralization. Reverse of neutralization, and it is also called as salt hydrolysis. So please listen carefully. This is called salt hydrolysis. In the name itself, we say salt hydrolysis. Salt hydrolysis means what happens when a salt is dissolved in water. And what type of salts? That is salts obtained by the means of weak acid, weak base, strong acid, weak base, weak acid, strong base. But not, and a very important point is this point, very important. Please note down in your classwork. Salts of strong acid plus strong base do not undergo hydrolysis. Continuation now. So there are 3 types. Actually, there are 4 types of salts here in case we can write, because 4th type we will not include in this section. But there are 4 types of salts. One is salts obtained by means of strong acid and weak base. Strong acid and weak base. So for example, ammonium chloride. How ammonium chloride is obtained? From weak base ammonia. When weak ammonia combines with HCl, weak base and strong acid, it forms ammonium chloride. So this is a salt obtained by means of strong acid and weak base. Second type of salt, salts of strong base and weak acid. Strong base and weak acid like sodium acetate. It's already we know how we got this sodium acetate. Sodium acetate, how we got when acetic acid is treated with sodium hydroxide. When acetic acid is treated with sodium hydroxide, it forms sodium acetate. So this is a salt of weak acid and strong base, because Acetic acid is weak acid and sodium hydroxide is strong base. So please listen carefully. And salt of weak acid and weak base, ammonium acetate, that is CH3COO, NH4. How does this forms? When ammonia weak base combines with acetic acid, weak acid, it forms ammonium acetate. So that's why this is a salt found by the combination of weak base and weak acid. So these are the three types of salts. Another type of salt is also there, that is called salt of strong acid and strong base. Salt of strong acid and strong base. Salt of strong acid and strong base, like NaCl. How NaCl is formed? When HCl combines with NaOH. When HCl combines with NaOH, that is strong acid, strong base, it forms salt obtained by the means of, this is strong acid, as we know. This is strong base. So this is salt obtained by the means of strong acid and strong base. As these salts of strong acid and strong base do not undergo hydrolysis, that's why this is not included. So we have to work out only these three, 1, 2, and 3. So salt of strong acid and strong base do not undergo hydrolysis. That is the first point. And remaining all these type of salts like ammonium chloride undergo hydrolysis, sodium acetate undergo hydrolysis, ammonium acetate also undergo hydrolysis. Like salt of weak acid and weak base undergoes hydrolysis, salt of strong base and weak acid also undergo hydrolysis. So by this what you can say, 1, 2, 3 type salts undergo hydrolysis. Undergoes hydrolysis. Hydrolysis means when they dissolve in water. So salt of 1, 2, and 3 will undergo hydrolysis. And fourth type salt, that is salt of strong acid and strong base, will not undergo hydrolysis. That's why we have taken only 3 types. So please note it down in your classwork. So what are the different types of salts we have? Salts of strong acid and weak base, salt of strong base and weak acid, salt of weak acid and weak base, and salt of strong acid and strong base. However, salt of strong acid and strong base do not undergo hydrolysis as they ionize in water. Whereas salt of strong acid and weak base will undergo hydrolysis, salt of strong base and weak acid undergo hydrolysis, and salt of weak acid and weak base undergo hydrolysis. So 1, 2, 3 types of salts undergoes hydrolysis, whereas fourth salt do not undergo hydrolysis. So please listen carefully. I hope you have copied in your classwork. Next continuation. You have to point whatever I'm writing and whatever the slides they are showing, you have to write it in your classwork. Then only you can better understand the lesson. Otherwise, it is very difficult to understand this concept. Not only this concept, any concept. So all the subjects, first of all, whenever they have shown the PPT on the screen, so first please write down the PPT in your classwork, then try to listen carefully. 100% you will understand clearly the concept. So if you can understand the concept very easily, you can solve the questions. So please do that immediately. Next continuation. So first type of salt, salt of strong acid and weak base. As I told you, ammonium chloride is an example. These are the examples: ammonium chloride, ammonium nitrate, AlCl3, etc. All these are called as salt of strong acid and weak base. These salts completely ionize in this aqueous solution. Ammonium chloride dissociates to form ammonium ions and chlorine ions. Ammonium ion so formed undergoes hydrolysis and given ammonium hydroxide and H plus ions. So these ammonium ions, when dissolved in water, what happens? Undergoes hydrolysis and forms ammonium hydroxide weak base and H plus ions strong acid. So that's why again it is giving weak base, that is ammonium hydroxide, and strong acid, that is H plus ions. So this is called salt of strong acid and weak base. And this type of hydrolysis, we call it as, what type of hydrolysis we'll call it as, that also I'll tell you. Please note it down. So when ammonium ions combines with water in the water and forms ammonium hydroxide, and so this type of hydrolysis, the cation of the salt undergoes hydrolysis. Here, since the cation of the salt undergoes hydrolysis because conjugate acid of the base is strong. So this type of hydrolysis is called as cationic hydrolysis. What is this called? Cationic hydrolysis. Why it is called cationic hydrolysis? Because the cation of the salt undergoes hydrolysis with water. So this is called cationic hydrolysis. Please note down this. Very important. They'll ask in the examination this, from this type of from this concept also questions, theoretical question also apart from numericals. So since the cation of the salt is combining with water, it is called as cationic hydrolysis. When ammonium chloride is dissolved in water, what happens? It forms ammonium ion and chlorine minus ion. And this ammonium ion so formed undergoes hydrolysis and given ammonium hydroxide and H plus ions. So like this reaction takes place. So that's why since cation of the salt is undergoing hydrolysis, we'll call it as cationic hydrolysis. Cationic hydrolysis. And to form, so this is forming cationic hydrolysis. So for this, the hydrolysis constant is calculated. Hydrolysis constant Kh is equal to concentration of ammonium products, that is concentration of ammonium hydroxide. Note down this also, into concentration of H plus ions by concentration of ammonium chloride, that is by concentration of M plus ions, that is H plus ions, NH4 plus ions, sorry, by concentration of ammonium plus ions, because water do not have any concentration. So ammonium and this reactant, this is product. Just like equilibrium constant, Kh is equal to, that is called hydrolysis constant. What is Kh? Kh is equal to hydrolysis constant. Hydrolysis constant. So hydrolysis constant Kh is equal to concentration of products by concentration of reactants. What is the concentration of product? What is the product we formed? We got it, ammonium hydroxide into concentration of H plus by concentration of NH4 plus. So in this way, we'll write Kh value. And the hydrolysis of the Kh value is given. How to calculate Kh is equal to, from this you can write Kh is equal to ionic product of water, that is Kw by Kb also. So please note down these formulas. Kh is equal to Kw by Kb. So this is called cationic hydrolysis. What is this called? Cationic hydrolysis. Which type of salts will undergo cationic hydrolysis? The salt which is formed by the means of strong acid and weak base. Very important. Please note down. The salt which is formed by the means of strong acid and weak base undergoes cationic hydrolysis. In the entrance examination, they will give the salt, and by seeing the salt we can by seeing the salt we can say whether it is salt obtained by means of strong acid and weak base, or weak acid and strong base, or weak acid and weak base. So based on that, easily you can identify whether it will undergo cationic hydrolysis or anionic hydrolysis. So which type of salts will undergo cationic hydrolysis? Please note down, the salts which are obtained by the means of strong acid and weak base. Strong acid and weak base will undergo cationic hydrolysis. Please note it down. Very important. Next continuation. Next, salt of strong acid and weak base continuation. So ammonium ions combines with water and forms ammonium hydroxide and H plus ions. So ammonium hydroxide being unionized, this increases H plus ions concentration. Hence, the solution will be acidic and pH is less than 7. So for this type of salts, pH will be less than 7 because resultant is H plus ions will be formed. NH4OH being unionized, this increases H plus ion concentration in the solution. As H plus ion concentration are present in the solution becomes acidic, and as the acidic solution is taking place, so the pH will be less than 7. So please note down this point. So pH of the solution can be given by the formula for this type of salts. How to calculate pH? pH is equal to 7 minus half into pKb, that is dissociation constant of base, and minus half log C, that is concentration of salt. Concentration of salt. So in this way, we'll calculate the formula. So very important. Please note it down. So this type of hydrolysis is called what? Again, I'm writing here, cationic hydrolysis. Why it is cationic hydrolysis? Since the cation in the of the salt combines with water, hence it is called cationic hydrolysis. What are the important formulas from this? How to calculate hydrolysis constant? Kh is equal to Kw by Kb. If they ask hydrolysis constant, we have to use this formula. Kh is equal to Kw. Kw value is already we know 10 to the power of minus 14, and Kb value they will give you, and you can find out hydrolysis constant easily. So for this type of salts, which type of salts will undergo cationic hydrolysis? Salts of strong acid and weak base. Salts of strong acid and weak base. So only a thing you have to identify what type of salt it is. If you cannot identify what type of salt it is, we cannot apply the formula easily. And to find pH for this salt solution, we have to use the formula 7 minus half into pKb. How will you calculate pKb? pKb is equal to minus log Kb. For Kb, if you apply logarithm with minus sign, you'll get pKb. And what is log C? Log C is equal to concentration of salt. Concentration of salt. That is also will be given to you. So if they ask pH, we have to find like this. And if they ask KH, we have to find like this. So only three probabilities we'll be getting. Three types of questions from this. Only three types. For question number 1, please listen carefully. Question number 1. Which type of hydrolysis it will undergo? The salt will undergo cationic hydrolysis, anionic hydrolysis. Neither cationic nor anionic hydrolysis does not undergo hydrolysis. Like this, they'll give 4 options. Again, I repeat the statement. Again, anyway, we'll do that question definitely after the ending of the session. So only 3 possibilities are there from this concept. First possibility, which type of hydrolysis, that is cationic or anionic hydrolysis. Second possibility, they ask us to calculate hydrolysis constant, and that can be calculated by using the formula KH is equal to KW by KB, and KW value is already 1 in 10 to the power of minus 14. That is ionic product of value at 298 kelvins or 25 degrees C, and KB value they'll give you. So if you calculate that, you will get hydrolysis constant. Apart from that, this is question number 2. Question number 1, which type of hydrolysis? Question number 2, calculate hydrolysis constant by giving only Kb value. And question number 3, by giving Kb value, they'll ask us to, and concentration of salt, they'll ask us to find pH of the solution. So we have 3 types of questions only from this expected. So what are the 3 types of questions I have told you already? So I hope it is clear. And next, anyway, I'm going to write the questions and answers also. So please note it down. So in this way, we'll find out pH of the solution. Which solution? That is salt of strong acid and weak base. So first point number 1, salt of strong acid and weak base will undergo cationic hydrolysis because the cation of the salt will combine with water and forms base, weak base along with H plus ions. As the resultant solution is acidic, so pH will be less than 7 because NH4OH being unionized. This increases H plus ion concentration. As H plus ions are present in the solution, the pH of the solution will be less than 7, and on the whole, the solution will be acidic. And point number 2, how to calculate hydrolysis constant. Hydrolysis constant can be calculated by the formula KH is equal to KW by KB. And how to calculate pH for this type of solutions? pH is equal to 7 minus half into pKb minus half log C. So remember these 3 points, point number 1, point number 2, and point number 3. And finally, this is point number 4. So these 4 points, if you remember, 100% you can able to answer from this question, from this concept, the question given in the entrance exam. So please remember, for all the types of salts, you have to remember these 4 questions only. Anyway, we are writing that questions at the end of this chapter, at the end of this session. Next, continuation. Now, let us see the example. They have given one example. Calculate the pH of 0.2 molarity solution of ammonium chloride. Ammonium chloride is a salt which is made up of, what is the ammonium chloride salt is made up of? Ammonia is a weak base and HCl is a strong acid. So it is a combination of weak base and strong acid, first point. And Kb for ammonium hydroxide is given 1.8 in 10 to the power of minus 5. They have given already Kb value and they have given concentration of salt. So how to calculate pH? Straight away use this formula. pH is equal to 7 minus half into pKb minus log C straight away. So that is equal to 7 minus 1 by 2 into pKb. That is minus log of 1.8 in 10 to the power of minus 5. Minus log C, that is 0.2. Log 0.2, sorry. Here we have to substitute the formula. So log 0.2. So if we keep this again, this completely into bracket, first you solve this, automatically you'll get the answer. So let us see, 7 minus half into bracket log 1.8 10 to the power of minus 5. So minus 5, this becomes plus 5. So 5 log 1.8 minus log 0.2. Since log 0.2 is less than 1, because log 1 is 0, so this can be neglected. So straight away log 1.8. So log 1.8 value, since already we know that is 5 minus log 1.8. So this is 5 log 1.8 can be taken as 5 minus log 1.8, that is 7 minus 1 by 2 into 5 minus log 8 log 1.8. So it is equal to 5 minus log 1.8 value is 0.25. So 0.26 you can write. I'll just do calculation part. So 7 minus half into 5 minus log 1.8. 1.8 log is equal to 0.255. Sorry. One by 2 into 5 minus 0.25. So approximately I'm writing here. So that is equal to 7 minus 1 by 2 into 5 minus 0.25 is 4.74. 0.26 actually. So I'll write it again here for neat handwriting. 0.26. So 4.74. 4.74 divided by 2 is equal to approximate value I'm giving 4.74 divided by 2, it is equal to 2.37. So 7 minus, because half into 4.74, 7 minus 2.37. So you'll get the value in case of 7 minus 2.37, approximately you'll get 4.63. So approximate values I have taken rounding off, and let us see the exact answer for this. It is 4.9. So approximate we are getting 4.6 because we are neglected 0.2 also. If you count that also, you'll get 4.9 only. So exact answer is this, approximate value is this. Almost it is similar. Anyway, only the thing we have to know the methodology. So pH is equal to 7 minus half pKb minus log C. Here they have given concentration of the salt, as well as they have given Kb of base, and this type of salt will undergo cationic hydrolysis. So from this you can find out hydrolysis constant also. Kh is equal to, that is 1 in 10 to the power of minus 14 by 1.8 in 10 to the power of minus 5. Even you can do this also here, just for understanding I'm giving this. So 10 to the power of minus 5 going to numerator, 10 to the power of plus 5. So it is 10 to the power of minus 9 divided by 1.8. That calculation also you can do later on. Just for understanding you have given. So they can ask either to calculate pH, they can ask either to calculate KH, or they can ask which type of hydrolysis. So these are the 3 types of questions. And on the whole, the solution will be acidic. That's why its value is less than 7. I hope it is clear. So these type of questions are important for objective entrance exams. So please note it down and copy it in your classwork. Solution, if you don't copy, again you can see and write, because it is video lecture, so it is audio lecture, so anyway it is recorded video only. So please listen 3-4 times, then only you can understand easily. Next, continuation. Next type of salt is nothing but what? Next type of salt, it is salt of strong base with weak acid. Salt of strong base with weak acid. Examples: sodium acetate, potassium cyanide, potassium phosphate, etc. These salts completely ionize in the aqueous solution by giving anions as well as cation. And here, very important thing. See, for when sodium acetate is dissolved in water, it forms is dissolved in a solution. It forms acetate ion along with sodium ion. This acetate ion here, this acetate ion, that is anion. This acetate ion anion combines with water. You can see the difference in the previous case. H plus this cation combines with water, and here anion is combining with water and forms acetic acid again along with OH minus. On as concentration of OH minus is more, so the resultant solution will be basic. And so the pH will be greater than 7. The pH will be greater than 7. These are the 2 points. And as anion is combined with water, it is also called as anionic hydrolysis. And ionic hydrolysis. Sorry. Anionic hydrolysis. So this is called anionic hydrolysis. Why? Because the anion of the salt combines with water and forms acid, weak acid, along with OH minus ions. OH minus ions. So it is resultant solution will be basic. As a resultant solution is basic because concentration of OH minus ions is present in the solution. So pH should be greater than 7. pH should be greater than 7. And how to find hydrolysis constant for this reaction? KH is equal to Kw by Ka, because they will give, since weak acid is formed finally, so they will give dissociation constant of acid, not base. In the previous session, we have seen KH is equal to Kw by Kb, and but here we have to take KH is equal to Kw by Ka. So it is very, very important. So they can ask which type of hydrolysis, that is by seeing the salt. So if the salt is made up of strong base and weak acid, strong base and weak acid, how can we say this is strong base and weak acid? This is prepared by means of acetic acid when combined with sodium hydroxide, weak acid and strong base, that is sodium hydroxide. It is strong base. Then it forms sodium acetate along with water. So this is called salt obtained by the means of weak acid plus strong base. So by seeing the salt, if we don't identify whether it is type of which type of salt, it is difficult to write the answers in the examination. So it is my sincere request that you have to understand what type of salt it is, because all the salts are categorized into four categories. First is salts obtained by the means of strong acid and weak base. Second is salts obtained by the means of strong base and weak acid. Third is salts obtained by the means of weak acid and weak base. And fourth is salts obtained by the means of strong acid and strong base. And salts obtained by the means of strong acid and strong base do not undergo hydrolysis. That in the first slide only I have explained. So only these three types of salts you have to remember. So that is, first type of salt is what? Salt of strong acid and weak base. Second type of salt, salt of strong base and weak acid. And salt of strong acid and weak base will undergo cationic hydrolysis. Why it is undergoing cationic hydrolysis? Because the cation of the salt, that is ammonium ions, combines with water in that case and forms weak acid again, and forms weak base, and forms weak base. And in this case, what happens? The anion of the salt, here the anion of the salt combines with water and forms weak acid. So due to which what happens, it is called anionic hydrolysis. And as due to the formation of OH minus ions are present in the concentration of OH minus ions will increase due to the anionization of weak acid. So the resultant solution will be basic. As the resultant solution is basic, pH is greater than 7. It is clear now. And how to calculate pH for this type of salts? Let us see now. Answer. So hence solution will be basic because pH is more than 7, and pH of the solution can be calculated by using the formula pH is equal to 7 plus half pKa, half into pKa plus log C, half log C. Total it is half log C. 7 plus half pK plus half log C. So remember this formula. Here also we have to remember point number 1. This type of salt will undergo anionic hydrolysis. Remember these points. Please note down in your classwork. This type of salt will undergo what type of hydrolysis? Anionic hydrolysis. And point number 2, how to calculate hydrolysis constant. Hydrolysis constant KH is equal to hydrolysis constant for this type of salt KH is equal to Kw by Ka, because they will give weak acid is formed. And third point, what is third point? pH is greater than 7, because the solution is basic, pH will be more than 7. And fourth point, to calculate pH, use the formulas to calculate pH is equal to 7 plus half pKa plus half log C, where pK is called negative logarithm of Ka, that is dissociation constant of acid, and log C is called concentration of salt. Concentration of salt. C is called what? Concentration of salt. So in the first case also you have to remember like this 4 points. Second case also you have to remember like this 4 points. And third case also you have to remember like this 4 points. So all the three types of salt, these 4 points are important. If you can remember these 4 points, easily you can understand and easily you can find out the questions in the entrance exam. Because from the entrance exam, for the entrance examinations, you can get a question from either buffer solutions or salt hydrolysis or solubility product. So you should be thorough with all these three topics mainly. And fourth is pH problems in this chapter. So total four important concepts in this chapter. And apart from Lewis acids of theories of acid base and salts. So total five important concepts. Anyway, this concept, these five important concepts again we'll discuss in the summary of the chapter. So what to do? But here itself, now at this position, you have to remember these 4 points for this type of salt. First type, second type, third type also. Next, we'll see question on this. So please note it down. Continuation. Calculate the pH of 0.01 molarity of KF solution, that is potassium fluoride. It is a salt. Potassium fluoride is formed by the means of weak base and strong acid. Sorry, strong base and weak acid. It is salt are found by means of strong base plus weak acid. How we can say? Because potassium hydroxide plus HF, hydrogen fluoride. Hydrogen fluoride is a weak acid and potassium hydroxide is strong base. And due to this, it forms KF. KF along with water. So, and pH of the solution Ka of HF is given hydrogen fluoride, that is 6.6 in 10 to the power minus 4. So for this simple derivative question, so pH is equal to 7 plus half into pKa plus half log C. So let us do now. So pK value is equal to negative logarithm of 6.6 in 10 to the power of minus 4. This can be taken as 4 minus log 6.6. Separately I'm doing it so that you can understand it better, because 10 to the power minus 4 minus minus gets cancelled. So it is become 4 minus log 6.6. So log 6.6 value will be, I'll write it here, please note it down. 6.6 log is equal to 0.82. 0.82. Just I'll write here. So this becomes 4 minus 0.82, that is equal to approximately 3.18. 0.82 minus 4 is equal to 3.18. So pK value is 3.18. Similarly, log C. What is log C? Log of 10 to the power of minus, because 0.01 can be taken as 10 to the power of minus 2, because 1 by 100 you can take. So 1 in 10 to the power of minus 2. So we can take log C is equal to log of 10 to the power of minus 2. It is equal to minus 2 log base 10. Log base 10 to the base 10 is log 10 to the base 10 is 1. So it is equal to minus 2. So straight away you can write 7 plus half into pK value, it is 3.18, plus log 10 to the power of minus 2, because log C value is half into minus 2. This 2 and 2 gets cancelled, it is becoming minus 1. So 1 by 2 into 3.18, 3.18 by 2, it is equal to so 3.18 divided by 2 is equal to 1.59. So 7 plus 1.59 minus 1, because this minus into plus minus, so minus 1, it becoming, so 7 plus 1.59, 8.59 minus 1, it becomes 7.59. So how much it is? 7.59 approximately. Let us check the answer. It is 7.59 exactly, we got it. So in this way you have to calculate. So please note it down. Calculate the pH of 0.01 molarity of KF solution, and pH of the solution is given. This is only model number 1. So to calculate pH for this type of solution, since this is a salt obtained by the means of strong base and weak acid, if you don't know identification of this, you cannot apply the formula. And Anyway, you can apply the formula easily because they are given Ka values. Definitely, as they are given Ka values, you can say it is salt obtained by means of strong base and weak acid. So to calculate pH is equal to 7 plus half pKa plus half log C. So pKa, how to calculate pKa? That is negative logarithm of Ka. Ka is given 6.6 in 10 to the power minus 4. So minus log 6.6 in 10 to the power minus 4 can be taken as minus of minus becomes 4. So 4 minus log 6.66. So log 6.6 is approximately 0.82. So it is equal to 3.18. So log C valued log 10 to the power minus 2. So log 10 to the power minus 2 can be taken as minus 2 because minus 2 log 10 to the base 10. Log 10 to the base 10 is 1. So minus 2 into 1 is minus 2. And 7 plus half 1 by 2, half 1 by 2 into 3.18 plus 1.2 into minus 2. Applying the formula. So you'll get it as 7.59. So in this way, you can do the numerical. It's very, very important model. So it is clear now. Next, we are going to discuss third type of salt. We have given the questions based there itself so that it will be easy for you to identify. Next, third one, salt of weak acid and weak base. Third type of salt is weak acid and weak base. So this type of salts, nothing but it is found by the means of, for example, how this salt is found when acetic acid. Acetic acid is a weak acid, since already we know, because it do not ionize completely. Plus ammonium plus ammonia is also weak base. When these two combines together, it forms ammonium acetate, that is CH3COO. This H will combine with ammonia and forms ammonium acetate. Ammonium acetate. So this is a salt obtained by means of weak acid and weak base. Weak acid and weak base. This is a salt of type. So these salts ionize in water. The ions formed undergo hydrolysis as follows. So first, the salt combines to form acetate ion as well as ammonium. So this ammonium ion, this should be ammonium ion. It gives to form two ions, that is acetate ion as well as ammonium. That is anion as well as cation. So in this case, what happens? In the previous case, we have observed either cation or anion will be combining with water. But in this case, we'll observe that both cation and anion will combine with water and forms weak acid and weak base again. Weak acid and weak base again. So both cation and anion remains partially dissociated to form. So that's why what happens here. This type of hydrolysis is called as both cationic and anionic hydrolysis. Please note down this point. Both cationic and anionic hydrolysis, very, very important. So this type of salt is found by this type of hydrolysis is called as cationic as well as anionic hydrolysis, because cation combines with water as well as anion. So anion acetate ion and cation ammonium ion will combine with water to form weak acid and weak base. So that's why both cationic and anionic hydrolysis, both cationic and anionic hydrolysis. And how to find hydrolysis constant for this type of salt? KH is equal to KW by Ka into Kb. For this type of salts only, they will give both Ka value as well as Kb, because acid is formed as well as base is formed. So that's why they will give both Ka values and Kb values. So in this way, we can find out hydrolysis constant for this. Hydrolysis constant for this. So please note down. So the salt of weak acid and weak base undergo hydrolysis to form weak acid and weak base again. Weak acid and weak base again. And this type of hydrolysis is called both cationic and anionic hydrolysis, since cation as well as anion combines with water in this case to form weak acid as well as weak base. And to find hydrolysis constant for this type of acids, we have to use the formula KH is equal to, for this type of salts, we have to use the formula hydrolysis constant. Hydrolysis constant KH is equal to KW by Ka into Kb. KW, that is ionic product of water, by dissociation constant of acid into dissociation constant of base. So please note down this in your classwork. Again, you will not understand. Continuation now. Since acetic acid forms acetate ion plus H plus ions, and ammonium hydroxide again dissolves to form ammonium ions and OH minus ions. On the whole, it forms water. So the pH of this salt will be neutral. So for these salts, it can be shown that degree of hydrolysis is independent of concentration of salt. So their pH is given by pH is equal to, how to calculate pH for them? pH is equal to 7 plus pKa by 2 minus pKb by 2. So for this type of salts, we have to calculate pH like this, and how to calculate hydrolysis constant. KH is equal to Kw by Ka into Kb. And what type of hydrolysis it will undergo? So point number 1, point number 2, and resultant pH will be 7 or less than 7. It can be anything. And point number 3, what is this? It undergoes both cationic. Why am I writing so many times? Because this type of questions we have seen in mains and even NEET also. So this type of salt will undergo both cationic and as well as anionic hydrolysis. Anionic hydrolysis. So please note it down. Very, very important. Very, very important. Let us see a question based on this. So if Ka is equal to Kb, in this we have different cases. It can be neutral, it can be acidic, it can be basic, as I told you. So if Ka is equal to Kb, then Pk is equal to Pkb, solution is neutral. If Ka is greater than Kb, so automatically Pk is less than Pkb, so solution is acidic. So if Ka is less than Kb, Pk is greater than Pkb, so solution is basic. So in this we have three conditions. As I told you before, only for the first type of salt, it is acidic. For the second type of salt, the resultant solution is basic. pH is greater than 7. But for this type of salt, we cannot say whether it can be acidic, it can be neutral, or it can be basic, because it depends upon purely Ka and Kb values. So if Ka is equal to Kb, that is this ionization constant of acid is equal to ionization constant of base, we can say pK is equal to pKb. So solution becomes neutral. So pH value becomes 7. And suppose if Ka is greater than Kb, so pK is less than pKb, because Ka means pK negative log. So solution is acidic. So for this, pH is less than 7. pH is less than 7. And for this, if Ka is less than Kb, then Pk is greater than Pkb. So automatically solution is basic. So it purely depends upon Ka and Kb. If Ka is greater than Kb, acidic solution. If Kb is greater than Ka, basic solutions, and pH will be greater than 7. So in this case, we cannot say whether the solution can become acidic, neutral, or basic. Depends upon purely Ka values and Kb values. So this point is very, very important. Please note it down. And how to find pK, how to find for this type of solution, how to find pH of the solution. Just see now. I'm just clearing it now. So how to find pH of the solution? pH is equal to 7 plus pKa by 2 minus pKb by 2. So like this. Now let us see the question. Calculate pH of 0.5, 0.15 molarity solution of ammonium acetate. What is the formula of ammonium acetate? CH3COONH4. CH3COONH4. So it is nothing but salt of what? Weak acid and weak base. So it undergoes both cationic and anionic hydrolysis, both cationic and anionic hydrolysis. Point number 2. So Ka for this acetic acid is given 1.8 10 to the power minus 5. Kb is 1.8. Since Ka is equal to Kb for this, since Ka is equal to Kb, the solution is neutral. Straight away we can say no need to calculate anything. Even if you calculate also, you'll get the same thing. Because Ka value is given 1.8 10 to the power minus 5. Kb is also for ammonia is given 1.8 10 to the power minus 5. So on the whole, the solution becomes neutral. So Ka is equal to Kb is equal to neutral. So since Ka is equal to Kb, the solution is neutral. Implied solution is neutral. So therefore, pH is equal to 7 straight away. Without applying the formula, straight away we can do. Let us see the answer now. So it is equal to 7. So like these tricky questions in the examination, you without using anything, I have done directly pH is equal to 7, because very important point is Ka is equal to Kb for this solution. For this type of solution, they have given, even though it contains 0.15 molarity solution of ammonium acetate, but since Ka of our acetic acid is equal to Kb of ammonia, we can say since Ka is equal to Kb, the solution becomes neutral. If Ka is greater than Kb, the solution becomes acidic. If Kb is greater than Ka, the solution becomes basic. In those cases, we have to calculate by using the formula. How to calculate pH for this formula? For this question's pH is equal to 7 plus half pK by 2, that is pK by 2 minus pKb by 2. So you can see in the previous sessions, you can see that formula. So like this you have to note down. So for this, how to calculate pKa? pKa is nothing but 7 plus half pK minus half pKb by 2. So in this case, hydrolysis constant KH is equal to, how to calculate KH for this type of salts? KH is equal to Kw by Ka into Kb. So these are the things we have to remember. And so please note down. I think you understood this problem. I hope it is clear. Next continuation. So let us write some more important points regarding salt hydrolysis. So I'll write here first type of salt, one important table I write. So please note down. Salt of strong acid and strong base. Salt of strong acid and strong base. Nature is neutral. Here I'll write salt, nature. I'll write here separately. So you use this table. Salt, nature, hydrolysis constant KH, and degree of hydrolysis. Degree of hydrolysis. One more point I'm adding. Degree of hydrolysis. And finally, how to calculate pH. pH at 25 degrees C. So 4 columns I am making. Column number 1, column number 2, column number 3, column number 4, and column number 5. So salt of strong acid and strong base nature, it is neutral. What is the nature of this salt? So again, I'll write it down. So please note down, this table is very, very important. So it's very difficult to draw with by the means of digital pen. So please try to understand degree of hydrolysis and nature. I'll move it little bit. Here I'll move it, nature. And then is salt. First one, salt of strong acid plus strong base. Nature, it is neutral because it will not undergo hydrolysis. Hydrolysis constant. Again, it has been linked, line is linked up. So KH, no, because it will not know hydrolysis. No hydrolysis. And pH, it is equal to 7. Second type of salt, strong acid plus weak base. Strong acid. So please note down in your classwork also. Nature of solution, acidic. Nature of solution is acidic. Sorry, it is nature, we have to write salt of strong acid and weak base. So nature means here salt of strong acid and weak base, it is cationic hydrolysis. Cationic hydrolysis. And for to find KH, KH is equal to Kw by Ka. And degree of hydrolysis H is equal to, this is H is equal to, one more formula I'm attaching, root of KH by C. and pH will be 7 minus salt of weak base and strong acid. So 7 minus half into pKa minus half log C. Half log C. So these formulas already I have given. So if you are unable to understand, I'll write it here again. Half log C. Next, third type of salt. Salt of weak acid, strong base. Anionic hydrolysis. Anionic hydrolysis. So KH is equal to Kw by Kb, and H is equal to root of KH by C. And how to calculate pH? 7 plus half pKa plus half log C. 7 plus half pKa plus log C. This is pKb. And this is half pKa plus half log C. 1 by 2 log C. And fourth type, weak acid plus weak base. Both cationic and anionic hydrolysis. And for this type of salts, KH is equal to Kw by Ka into Kb. And decay of hydrolysis H is equal to root of KH only, no C. And for this type of salt, how to calculate? 7 plus half pKa minus half pKb. That's all. So this table is very, very important. This table gives you clearly all the 4 questions based on salt hydrolysis, how to calculate numericals also. So please note down this table. I thought of bringing this table in the type of PPT, but it is not there. So that's why we have given it written like this. So please note down this very, very important table. Entire salt hydrolysis chapter will be completed here. Salt hydrolysis topic will be completed here. So we have done 3 questions based on this. Some more questions we'll do right now, so that it will be clear for you. This concept will be clear. So I hope you have noted down. So if you are not noted down when I'm dictating also, when we are watching the video, you can play back this for many times and you can see it clearly. So next, we are going to do questions on salt hydrolysis. Questions on salt hydrolysis, some more questions. Because we have done only one type of model. Now we will see another types. Questions on hydrolysis. Salt hydrolysis. Question number 1. So please note down. A salt of, a salt of weak acid and weak base undergoes option A, cationic hydrolysis, option B, anionic hydrolysis, option C, both cationic hydrolysis and anionic, both cationic and anionic, and option D, neither cationic nor anionic. Anionic hydrolysis. So this is the question. So it will undergo cationic hydrolysis, anionic hydrolysis, both cationic and anionic hydrolysis, neither cationic nor anionic hydrolysis. So answer, as we know, the answer is C, because weak acid and weak base, such as example, what is the example? Ammonium cyanide, because hydrogen cyanide is there. KF, potassium fluoride. Sorry, this KF will not come. Ammonium cyanide, like ammonium acetate, etc., will undergo this type of hydrolysis. These are nothing but examples: weak acid and weak base. So if you identify the salt, it will be easy. They will not, sometimes they give directly salt also without formula. So we have to identify whether it is weak acid and weak base. Here I have mentioned in the question a salt of weak acid and weak base. Clearly I have mentioned weak acid and weak base. But in the examination, they'll give directly salts like ammonium cyanide undergoes sodium acetate, sorry, ammonium acetate undergoes, a salt of ammonium cyanide undergoes cationic hydrolysis, anionic hydrolysis, both cationic and anionic, neither cationic nor anionic hydrolysis. So like these questions are important. Please note it down. Next question number 2. I hope you have copied this. If you don't copy, just copy it on in the classwork. Question number 2 now is right. The aqueous solution of sodium cyanide, NaCN, sodium cyanide is basic in nature, is basic in nature. This is due to hydrolysis of, this is due to hydrolysis of option A, sodium ion, option B, cyanide ion, option C, both cyanide ion and sodium ion, and option D, isocyanide ion, that is NC ion, isocyanide ion. So you know this, the aqueous solution of sodium cyanide. Sodium cyanide is a salt of strong base and weak acid. Strong base and weak acid. So sodium cyanide. So if you identify, then only can I easily identify it. If you identify the salt, the question is over. So it is a combination of strong base and weak acid. So it undergo what type of hydrolysis? Anionic hydrolysis. So in this, what happens? Anionic hydrolysis means the anion will combine with water. So what is the anion in sodium cyanide? It is cyanide ion. So answer is B. Very, very important. Like this theoretical questions also you get apart from numericals. Anyway, numericals we have done. So theoretical questions also it is important. Next question number 3. So I hope you have noted it. Next question number 3. Third important model on salt hydrolysis. With this lecture, you will be perfect in salt hydrolysis. You can take any book and you can solve any type of questions. The hydrolysis constant of, this is third question, the hydrolysis constant of sodium acetate, CHCONA, is given by option 1, KH is equal to KW by KA. Option 2, KH is equal to KW by KB. Option 3, that is C, KH is equal to KW by KA into KB. And option D, KH is equal to KA into KB. KH is equal to KA plus KB. They are given 4 options. So for this also you have to identify the salt. What is the salt called? It is combination of weak acid and strong base. Weak acid and strong base means it undergoes what? Either it undergoes anionic hydrolysis or cationic hydrolysis. By that you can understand easily. So in this, the anion strong base means it results in the formation of basic solution. So in this the anion or cation will be there. So in this, what is happening here? So you can just see and tell. So it is undergoing weak acid and strong base. So weak acid, the cation and the anion. So here the anion CH3CO minus will combine with water and form weak acid again. So that's why it is called cationic hydrolysis. So this will undergo what type of hydrolysis? Cationic hydrolysis. Since it is undergoing cationic hydrolysis, the hydrolysis constant formula is equal to KH is equal to KW by KA. Option A. If it is undergoing anionic hydrolysis, it is KH is equal to KW by KB. If it is undergoing both cationic and anionic hydrolysis, KH is equal to KW into K into KB. So anyway, this is ruled out. So answer is first option. First option, very, very important. I hope it is clear. Next, question number 4. Question number 4. Anyway, we have done pH problems. So now, apart from pH problems, what are the possible theoretical questions I am working it out? So please note it down. The hydrolysis constant of the hydrolysis constant of MX. This is the type of salt MX is given. Is they're asking hydrolysis constant given. What is given? KB is of MOH. KB of MOH, that is weak base, is 2 in 10 to the power of minus 6, and Ka of HX is 5 in 10 to the power of minus 7. 5 into 10 to the power of minus 7. Option, first option, 10 to the power of 2. It is very, very typical question and easy. Second option, 10 to the power of minus 2. Third option, 10 to the power of minus 3. And fourth option, we have 10 to the power of 3. So now for this, I'll do solution. Since they have not given salt, the salt of type MX. M can be cation, X minus will be anion, it can be anything. So this is the salt. So, and they have given MOH is the base and HX is the acid. So since they have given Ka and Kb values, this should be definitely salt of weak acid and weak base. Salt of weak acid and weak base. And to find salt of weak acid and weak base, it undergoes both cationic and anionic hydrolysis. So it undergoes both cationic, because in this case the cation will combine with water, as well as and anionic hydrolysis. Anionic hydrolysis. So for this, hydrolysis constant is calculated by the formula KH is equal to KW by Ka into Kb. And we know Kw value is ionic product of water, it is equal to 10 to the power of minus 14 by Ka value, it is Ka is 5 in 10 to the power of minus 7, and Kb value is given 2 in 10 to the power of minus 6. So minus 7 minus 6 becomes 10 to the power of minus 13. So this becomes 10 to the power of minus 14, and this 10 to the power of minus 13 going to the numerator becomes 10 to the power of plus 13 divided by 5 into 2. So this becomes 10. 10 goes to numerator, 10 to the power of minus 1. So this becomes, so 10 to the power of minus 13, 10 to the power of minus 14 becomes 10 to the power of minus 1 divided by 10. So 10 to the power of minus 1 can be taken as 1 by 100. This should be taken as 1 by 100. So it should be 10 to the power of 2, 10 to the power of minus 2. So answer is what? Second option. Because 10 to the power of minus 1 coming to denominator becomes 10 to the power of 1. So 10 to the power of 1 into 10 becomes 1 by 100. So it is equal to 10 to the power of minus 2. So like these questions you may expect in the examination apart from pH problems. So apart from pH of the salt hydrolysis. So you have to do like these questions also. Next question number 5, last question, so that all the models will be covered. And some more questions you can do it by yourself. At the end of chapter anyway, we are going to do tough problems also. These are also looking easy, but they are without idea, it is very difficult. Next question number 5. The hydrolysis constant. The hydrolysis constant. The hydrolysis constant. KH of a salt. KH of a salt of NaOH and a weak acid. Of NaOH and weak acid. They have given NaOH and weak acid. And weak acid, that is HX, comma, if the Ka of the acid, Ka of the acid is 2 into 10 to the power of minus 6 is 2 into 10 to the power of minus 6 is option 1, 5 into 10 to the power of minus 8, option 2, 5 into 10 to the power of minus 6, option 3, 5 into 10 to the power of minus 9, and option D, 2.5 into 10 to the power of minus 7. 2.5 into 10 to the power of minus 7. So first we need to identify the salt obtained by the combination of these two. Since it is strong acid, strong base and weak acid, so straight away we can take it is salt obtained by the means of solution I'm doing here. Solution for this, since it is a salt obtained by the means of strong base and weak acid. Strong base and weak acid. So strong base and weak acid will undergo what type of hydrolysis? It is cationic hydrolysis or anionic hydrolysis. Since they have given already Ka, so it is nothing but cationic hydrolysis, weak acid because strong base and weak acid. So straight away we can take Kh is equal to Kw by Ka. So by this you can say that is 10 to the power of minus 14. This is the value of ionic product of water at 25 degrees C, and Ka value is given already. It is given how much? 2 in 10 to the power of minus 6. So 10 to the power of minus 10 to the power of minus 6 going to the numerator, 10 to the power of minus plus 6. So 10 to the power of minus 6 plus 6 minus 14, it is minus 8 by 2. This we can take it as 10 into 10 to the power of minus 9 by 2 per cancellation. So it is answer is 5 in 10 to the power of minus 9. So option is third option. 5 into 10 to the power of minus 9. So like these small questions also you may expect in the entrance exams. It is small, but it's more confusing and you will not remember at the time of examination. So you have to do like this. I hope it is clear. So these are questions we have done so far. Salt hydrolysis concept is over. Very, very important concept. So please note down the solution. And with this, we have completed salt hydrolysis successfully. And in the next session, we'll do the last topic, that is solubility product. I hope you understood everything clearly. Thank you all.